Good morning. Welcome back to Mechanical Engineering Practice and Graphics. We will be covering this week the fourth chapter of the book. This is a topic that most of you are already familiar with, but some of you are still struggling. This is the time just to formalize adding relations and dimensions to sketches. First, I would like to start with a friendly reminder that next week we will have the first midterm. It will be exactly the same as the first quiz. It will be just one model in SolidWorks. You will have uh, 1 hour and a half to do it. It's the same time as the quiz. Uh, Again, you will have to upload the part file and the PDF file to Blackboard the same way we just did for the first quiz. But now this is a midterm. It's just more important in the grade. There are two midterms in the semester and one final exam in December. Now, but by the midterm, all of you should have already installed SolidWorks. Well, we are in finishing the fourth week of the semester, and the midterm will be in the fifth week of the semester. Now, if you don't have SolidWorks, install it or ask Tech Cafe to give you a computer with SolidWorks already installed. Remember, you can reach me out via email or and we can schedule a meeting in WebEx to assist you installing it if you are unsure on how. So far we have done 2 homeworks, and this week we will be doing the third homework out of 10 homeworks. Remember that I am grading attendance based on the homeworks. If you submit your homeworks on time, then your attendance should be fine. Okay, let's start. The origin in the sketches. I already talked about this in the second week. Um, Basically, when you open a sketch in SolidWorks, down here you have these colorful arrows. These show you the orientation of your sketch. If you are in the 3D environment, you will see the three axes, X, Y, and Z. And if you are in a 2D environment, well, you will only see two of them, X and Y. Now, this axis follows the right-hand rule. Uh, Once you are in statics, I guess you will be learning the right-hand rule. Basically, if you point your hand with the four fingers pointing in the X direction and then you roll them up following the Y direction, you will have your fat finger pointing in the Z direction, basically. You will learn more about this further in your career. But what I want you to see here is these two red arrows. These represent the position of the origin in your coordinate system. Basically, this will be the point 0, 0. Now, every line you draw in SolidWorks, every point you draw in SolidWorks is related to this point. And the computer is basically storing the answer to this question. How many steps in X and how many steps in Y do I have to walk or distance in X and Y is there from the origin to any given point? Those are called the X, Y, and Z coordinates of any point and any line. Now, if you don't use this origin at all, you may have a very well-defined geometry, but it's not related to the origin. And we will elaborate on this during today's class. Uh, there is an option in which you can show or activate the planes just for you to get a better idea in which plane are you sketching. Basically, here in the top we have the hide all types button. This is just an eye. And if we deploy the menu, the first option on the right is hide and show primary planes. By activating that, we can see the front, the right, and the top plane. Again, the front, the right, and the top plane. And if we change the orientation, you will see that the coordinate system is changing. Now, if for example I am in the front plane, we only see X and Y. If we are in the right plane, we see only the Y and Z axis. And if we are in the top plane, we will see only the X and Y axis. Now in the isometric view, we should see all of the three axes. Let's take, for example, the first homework. You already did this geometry and three other geometries. But in that case, I didn't request the position of the origin. Like you could have your origin here, or maybe here, or maybe here, like anywhere in the drawing. Now, if this were the homework for this week, I will be asking the position of the origin. As you see down here in the bottom, I am specifying the location of the origin. And then all your geometry should be related to these 10 units and 10 horizontally and vertically from the origin. Now this is helpful once you are drawing several things in the same plane, because you have control on the actual size of your part. Okay? Now we're going to add relations. Let's go ahead and draw this straight line and a 3-point arc using the center point arc option. It can be in any plane. In my case, I'm going to use the front plane. So I click here in front plane, right click, and then I can create a sketch. I'm going to deactivate the primary planes. I only have the plane that I am drawing in. And again, you see down here we have our orientation. I can still change it. But if you see, my origin is showing me only the arrows that are inside the front plane, the x-axis and the y-axis. So if I try to draw like this, I will be like drawing in a 3D environment, but remember that the sketch is related to the front plane. So everything I do would be only in that plane, for example. You may think, okay, this line is in a 3D space. Not really. It is only in the front plane. And if I draw an arc, such as this one, again, that arc is only in the front plane. You see that it aligns with the front plane. Now, if by accident you are in this 3D space and you want to go back to the 2D space, you can press in your keyboard Control and then the number 8. And there it goes. You are aligned again with the front plane. Now what I want you to see is that we can add relations between this arc and this line. And there are two ways. The first is if you go here to display and delete relations and you deploy that menu, you will see that we can display or delete relations, we can add relations, or we can see if a sketch is fully defined. Let's go ahead and click the second option, and then it is asking me to select entities. So we can go ahead and select the line and then the arc. The order really doesn't matter. If you need to delete one of the selections that you did, you can right click in this list the component and then delete. And you see that now the line is dark blue again. If you want to select it again, you can just click it. And then here we have the possible relations. We have tangent relation, a fixed, or equal curve length. Fix is to fix everything in the space. And it will make your drawing already fully defined. But it's not true because I can still uh, change the length of this line, and the same goes for the length of the arc and even the position. So this fixed position is, or this fixed feature is not really that useful, and I rather you avoid it. Now the second option that you can do to add relation is you first click, for example, the arc, and then holding shift in your keyboard you select the second line, and again we already have the possible relations down here. Now see that there are no existing relations because I deleted the fixed relation that I did before. Now you can define equal length, and what it will do is that the length of this arc will be the same length of this line. Remember that the length of an arc is defined by the radius of the arc and the angle covered by the arc. Or I can also define that both of them are tangent, like this, which means that they approach each other, but they only touch in one single position. So if I zoom in there, we will see how the two lines are getting closer and closer, but they only touch in one point, mathematically speaking. Okay. So you already saw how to add that dimension, so I'm gonna skip these slides. Now, instead of having an arc, we're gonna replace one arc with another line. I can just select the line and click delete. And then I'm gonna draw a second line. And if you see, there is nothing special about these two lines. Now we can, remember, click one line, hold shift, and then click the second line. And there are relations for those two lines. They can either be horizontal or vertical. Now, if we go here in add relations and select both of them, we see that there are more possible relations. They both can be collinear, something like this. Maybe I should move like this. And then you will see that there is like a discontinuous or dotted line between these two lines, showing exactly that they both are collinear. I'm gonna press Ctrl C several times until we have it this way again. They both can be perpendicular, meaning that the angle that they form are 90 degrees in any way. And they don't even have to intercept to be perpendicular. Again, Control C to go back. They can be parallel, right? Not necessarily have the same length, just parallel. Or both of them can have the same length, which is equal. Now I can change the orientation of any of them, but the length is gonna be affecting both. So both of them has the same length. And see that if I define the length of this now, let's suppose that instead I want a short line, by changing this one automatically changes as well, because both of them has the same length. You can also define relations between a point and a line. For example, I can select this point, the origin, and then this line. And I can say, hey, you two are coincident. It means that the line of action of this line should go through that point, like this. You see that every time that I move it around, it is always pointing to the origin. Other thing that I can do between points and lines is calling the center point. Adding the relation of midpoint. And then you will see that the midpoint of this line will always be the origin, for example, and I can move it around. Maybe I want to delete this dimension and make this longer. You see? It will always be the midpoint of this line because of that relation that I added, the midpoint relation. Okay, we already saw this, so I'm gonna just skip a few slides again. Now let's go ahead and try to do a triangle like this. I can just select everything again and delete it, clicking delete in my keyboard. Now for this triangle, I will start here in the origin, not anywhere in the space. Here in the origin, I will first draw an horizontal line, then a vertical line, and then I'm gonna close it. Now as you see, we have a few relations here marked by these green boxes. This one is showing that the purple line is vertical, that this black line is horizontal, and that this corner is coincident to the origin. Also, we see that there is a dark gray area, and it's marking me a closed loop, a full area. We also see a black line here. This means that this line is fully defined. Then, it means that I cannot move the line, but if you see the point, it's still blue, and it means that I can change the position of that point along that line. Now, the difference between this point and this point up here, since this line is black, I can only move it along that line. But this point, since these two lines are blue, I can move it in any direction, as you see. The same goes for these two lines. I can change the angle or the position of this vertical line. Now look what happens if I define the length of these two lines. Just by defining it here. Let's suppose that I want this length to be 25 and also this other line to be 25. You may argue, okay, I defined the geometry of this triangle. Yeah. But again, this is just a provisional length. I can just drag this point around, or maybe I define this length after I already defined the other two, maybe 45. And now if I verify the length that I was defining for these two lines, it has changed. Because this is just a provisional parameter. This is not a restriction to the model. In order to add restrictions, you have to click here in Smart Dimension. And then I can define those lengths again. Now see that every time I define a distance, some of those lines are being defined or changing from blue to black. And now that I define these two distance or dimensions, um, the triangle is fully defined. I cannot move it, any part of it. And if I verify the dimension of this line, it has changed. It's not 45, it's 35. Now, the big difference between these two is you saw that I can have a blue triangle or a black triangle, and the blue triangle is not correct to answer this question because we have blue lines, there are no dimensions, and there are no relations. Whereas the black triangle is fully defined with black lines, it has dimensions in it, and it has relations as well, the green boxes. Now there are different ways of adding dimensions here, different controls. Uh, it's better if you just go with the smart dimension always. You can define everything with it, even angles. Let's suppose that I want to delete this dimension. So I just click it here and then delete. And maybe I want to define this angle here. You see? Now to define angles, I'm gonna do it again. To define angles, you have to click two lines and then a third position in which you want to measure the angle. You can measure either the inner angle or the outer angle, or even this angle. Okay. Now when you have a dimension like this one here and you click it, you will see several controls here. This is OK or restore original values and some more. You can change the direction of a dimension. Uh, but also here you have more controls on the dimensions. For instance, if you want to add a tolerance, and that's important next, you can add a plus or minus sign and then maybe a small measure. And basically when you do a blueprint like this, you are defining that the length of this triangle is nominal 25, and then you have a range in which you accept an error for this length, because you know when you are manufacturing things, it's not possible to have super precise measures. There will be always an error due to manufacturing imperfections or even material imperfections. So this tells the person that is actually manufacturing this that you are willing to accept an error of zero 0.1 millimeters, plus or minus, basically. And that opens this other topic, which is tolerances. You always have a basic dimension or a nominal dimension, and there are many different ways on representing a tolerance. The plus or minus that I just showed to you, or you can have bilateral tolerances. Maybe you are willing to accept more error in one direction than in the other. Or you can just put the maximum and minimum values that you are willing to accept, and anything between them is okay. Or you just have one uh, bounding value. So you might have either the minimum value or the maximum value. So there are different ways of representing tolerances. There are many more. These are just some uh, tolerances for the dimension, but you can also have tolerances for the geometry. For instance, maybe uh, there is some rugosity when you, for instance, you do this flat surface, but of course this is not entirely flat, so you might want to specify how much roughness do you want in this surface, for example. And those are called geometric tolerances, and you will learn more about this during the class. I just want to give you like an introduction on that this exists and that you can specify this in SolidWorks. These are important, for example, in engines to avoid or to minimize friction between moving parts. And you will see this TIP, I don't remember the meaning, but this is basically a geometric tolerance. And you can have as many as you want from different shapes. For example, this one means that surfaces A and B are perpendicular with a deviation of 0.01 degree, for example. So this has to be very precise. Or that the position of the center of this diameter of this hole can be with an error of 0.015 millimeters, for example. Or you're willing to accept an error in the diameter of the hole of 0.025 millimeters, plus or minus, and so on. There are many different ways to represent this kind of tolerances. I already showed you how to do angles, so I'm gonna skip this slide. But I didn't show you how to do it from points, so let's go ahead and draw these 3 circles. I'm gonna just delete everything again. Select everything and then delete. And then I'm gonna draw 3 circles somewhere. Now, to define the angle between points instead of lines, you first have to select the center point of the angle and then the other 2. So let's go to Smart Dimension. I first select the center point of the angle and then I select the other 2. And you see that I can define this angle now. And if I try to move it, one of those circles, the other ones will move again, preserving this angle. Well, and to specify diameters, you can do it outside, like this, specifying the the tangent lines or maximum positions of the circle. You can also specify it inside the circle, and it's the same. Or you can just have like an arrow pointing inside. Sorry. You can have just an arrow pointing inside, like this. And all of them are just equivalent of the same thing, defining the diameter of a circle. Now, when you're defining dimensions and tolerances, you might encounter this problem that maybe you define too many dimensions or too many relations. Let's take, for example, this drawing that we have here. It's a perfect square in which, well, the 2 vertical lines are indeed vertical or have the relation of being vertical, and the 2 horizontal lines are indeed horizontal. And this box here are telling us that this corner is coincident to the origin. Now, how many dimensions do we need to define a square? Basically the width and the height. And if you put 2 dimensions defining the height, it's over-constrained or it's over-defined. The usual way of fixing this kind of issue is by deleting either relations or dimensions. And I'll go with the later one. It's better if you delete the extra dimension and then just keep the square with two dimensions. So remember, the best way of fixing an overdefined sketch is by deleting dimensions. Okay, that was it for this class. It was a topic that most of you already know. Um, Again, we have homework for this week. It's an easy homework. It's just a revolution of a given geometry, very similar to what you did in the quiz. And if you do this homework very well, you will be more than prepared for the midterm, because the midterm is also a revolution of a given geometry. The same rules apply. The homework is due by this Sunday at midnight. You have to submit both the SolidWorks part file and a PDF with screenshots of your progress. So you just take a screenshot and paste it in Word and save the Word document as a PDF, and that's it. Not late submissions are accepted. Of course, you are not allowed to copy from anyone. And please use this naming convention. This is just to have everything organized. And the homework is this. Basically, is this profile of a pulley in a revolution. This is an eccentric revolution. It's the same as the quiz. But be careful, because this time I'm gonna verify the position of the origin. Check that I'm placing here the origin in the center. Here you will have to define several angles for these diagonal lines, all of these diagonal lines. And once you have this profile, you can use this line for construction in the bottom to do the revolution. Again, please remember to submit the SolidWorks part file, the PDF, and use the correct file naming convention. If you have any question, please send me an email or meet with me in WebEx during the time of the lab today. Or if you need to schedule an appointment with me, just send me an email and we can arrange something. Have a good day, everyone, and best of luck for next Monday for the midterm. Goodbye.